This is Learning Target 15, Quadratic Formula Part 1. The common theme the last couple of weeks has been finding the output, or finding the x-intercepts, finding when the outputs would be 0. And we did that last week with the zero product property and also solving using square roots. You may have thought about this last week during that second learning target from last week, the solving using square roots. You notice how all those examples didn't have a middle term. They just had the x squared, term, and then they had that constant term. So this would be useful for when you have a middle term and trying to find that output equal to 0. All right, so let's get into it. Think about how we might solve this for x. And when I say solve for x, trying to figure out what x values would give us an output that would be 0. Okay. And if you want to pause it and give it a try, you can. We're going to go ahead and try it together here. So let's think about what we did last week when we solved using square roots. So the first thing we did is we would get rid of the constant. So let's do that. Okay. So this gives us positive 5 x squared plus 3x. Okay. So we're not really allowed to combine these terms because they're not like terms. One has a squared and one is just to the first power. So we're not allowed to combine those. So what would we do? Well, if you remember to last week, we always like to have this by itself, this x squared term, because then we're able to take the square root. So I don't know, let's just try something. Let's just take away 3x. Both sides of the equation. And so then that does get us x squared isolated, but it does leave us with 5 minus 3x. And we know that we can't combine these because these aren't like terms, right? So we just have to leave that as 5 minus 3x. Okay, we still have x's on both sides of the equation. We're not usually a big fan of that. We usually like to have them on the same side. But if we move this back over to the other side, then we're back to where we started in the second step. So, I don't know, let's think of another algebra move that we can make. We can divide both sides by x. But remember, we said we usually don't like to do that because what if x is 0? Then it makes things weird. So, I'm just going to go with it and see what happens. We know we can always just go back if we have to. So, those cancel. But remember, we still need to divide this by x. So, then we're still left with an x over here. And then x squared divided by x, remember our exponent properties, we would just subtract 2 minus 1. This would just be x to the first power. Okay, so now we have x's on both sides still. Now we have an x in the denominator. If you're thinking, well, multiply both sides by x, well, then we're kind of back to where we started, where there's an x next to here and there's an x squared. So mathematicians, starting with Euclid back, long time ago, ran into the same problem. So our normal traditional algebraic approach here for solving for x, isolating x, is just not going to be, it's just not going to work. Okay, so a bunch of smart mathematicians came up with this formula to help with this. And that formula is right here. Yeah, looks fun, doesn't it? All right, so there's going to be a song attached to this. You're welcome to sing along. No, I'm not going to sing it right now, but you may hear me as I'm plugging things in. I may have like a musical tone to my voice as we're working through this. But yes, I will make sure there's a song that you guys will be able to listen to help with this that you'll never be able to get out of your head. All right. So these mathematicians that came up with this formula, they said, okay, think about a standard form equation. We've got our a value, our b value, and our c value. Okay, those are those coefficients and then the constant out here. Well, if we take this a, b, and c and we plug it into this formula, it will actually give us the x-intercepts. It will give us the solutions to this quadratic equation. Okay, so let's give one a try. So we've got our example here. Okay, so really probably the best thing to do is just go ahead and identify your a, b, and c. So that way you just know when you're plugging this into this complicated formula, you've got your a, b, and c situated. A is 1, in this case, right, the coefficient to x squared. B would be positive 3, and C would be positive 2. So just kind of put those off to the side so you can plug those in. And so let's go ahead and get into it. So we know that our solutions will be the opposite of B. All right, so just looking at that, the opposite of 3 would be negative 3, plus or minus the square root of B squared. And I'm going to write everything out, but I mean, going forward, I mean, you guys know 3 squared is just 9, so if you wanted to write a 9 there, that's fine. A little bit, shorten it up a little bit, but I'm going to write everything out. Minus 4 times A, 1, times C, which in this case is 2. So 4AC, 4 times A times C. Okay? It's all under a square root symbol. And then notice how this fraction bar goes across or underneath everything. So everything is divided by 2A. Can you imagine coming up with this formula? And some of the early mathematicians actually wrote this out. They weren't really quite sure how to attach letters to it yet. They just knew it worked. And so you can search Wikipedia. I think I Googled it. There was this Indian mathematician back from like the 9th century that actually wrote this all out in paragraph form. Can you imagine writing that out? Pretty crazy. Okay. So from there, yeah, we've got some work to do. We've just got to follow some order of operations. So usually it's best just to go right into this square root and get this taken care of first. Okay. So we've got 3 squared. So I'm just going to write this out so we have it all. So we've got 3 squared, which is 9. And then our next order of operation, we would want to make sure we take care of all this multiplication before we do any subtraction. Right? So I'm just going to put the subtraction. So we've got 4 multiplied by 1 multiplied by 2, which would just be 8. Okay, so that cleans up okay. And then 2 multiplied by 1 is just 2. All right, keep going. Nine minus 8, simple enough, it's just 1. Okay. All right, square root of 1 is just going to be 1. So really this is just negative 3 plus or minus, oops, get rid of that, plus or minus 1 divided by 2. Okay, now you might, as I'm been going through this one, might have wondered why I keep writing plus minus. Remember, quadratic functions can sometimes have 2 solutions, right? They can hit the x-axis at 2 places. And so when they developed this formula, that's why they did the plus minus, because sometimes there's going to be 2 solutions. All right. So really what this is this just breaks up into two parts. So we'll do the first one, which is negative 3 plus 1 divided by 2. And then the other one would be the bottom part, the minus. So negative 3 minus 1 divided by 2. Okay. And we're going to get our solutions there, which is our x-intercepts. So negative 3 plus 1 would be negative 2. Negative 2 divided by 2 is negative 1. So that's one of our solutions. Negative 3 subtract 1 is negative 4 divided by 2, which is negative 2. All right, so those are our 2 solutions. Those would be our 2 x-intercepts. There's one, and there's the other one. Okay, so these would be where this function would hit the x-axis. What I would recommend with this one, because if you're watching this video, you have a Chromebook or you have access to technology, or if you have the Desmos app, is open up Desmos. I do this all the time when I make practice problems. It's not cheating, it's just kind of checking your answer. Go to Desmos, and then as you're working through this, put this function into Desmos, right? Remember, you got to use x's, otherwise it doesn't like that if you don't use x. And then check to see if your x-intercepts hit where you thought they would when you use the quadratic formula. It can help to check your answer on those. Okay, I'm going to do another video for a second example, just because this video is getting kind of long. And stay tuned for that. Just go ahead and exit out of this one and then click on the next video.